to start chapter 2, and we're going to find out about frequency distributions. Before we get started, this doesn't need to be part of the video, but it helps that things plugged in. Okay. Should just about do it. Alright, we're ready to start chapter 2, section 2.1, about frequency distributions. Number 1, we've got the pen going here, the red color, and we're off to the races. Here's a small picture of a frequency distribution, and this is something that you will be able to make very easily. Notice before we get further along that the frequency distribution we've got here is a grouped frequency distribution. So why is it a grouped one? Because this column right here has groups for its classes. 0 to 50, 50 to 100, and so on. If it weren't grouped, it would look more like this. We have 10 here, 20 here for something else, 30, 40, 50. This would be ungrouped. This would be a group. One more item I'd like to mention before we move on is that if you take a look at this grouped one, it says 0 to 50 and 50 to 100. So suppose whatever you're talking about has a value of 50. Where do you put that value? Do you put it in this class or this class? Okay, very simple. What we do is make this one 0 up to, but not including 50. So the second class starts at 50 and goes up to, but not including 100. That's for grouped ones. Just a little note because I don't think the slides actually mention that particular item. Alright, let's go. Alright, just a few comments here. The ordered array is sort of obvious, from largest to smallest or vice versa. That's pretty simple. The distribution is, we're just showing what the data looks like. The frequency distribution is a display of those values. In other words, we're telling a story to someone else. As I just mentioned, we've got ungrouped ones, and we don't have classes that go from something to something. And a grouped one, where it's sort of like 0 up to, but not including 50. If you remember the previous slide. Frequencies. Now, if you've taken physics, you know some frequencies are a little bit different, although there is a connection between the two. That's how many of a certain data value you've got in a particular category. And we'll get back to that again. And the class is each row. So you could say this is a row in a frequency distribution. A row, a class, a category. It's all basically the same thing as far as we're concerned. So how do you create a frequency distribution? Number 1, you have to decide how many classes you need to have in your distribution or you want to have in your distribution. Well, here's something you need to write down. You want, most of all, you want between 5 and 20 classes. Now, one thing to remember also is that you're the one choosing, perhaps, how many classes you've got. If someone tells you in advance, I want 7 classes, then that's your job. Make it happen with 7 classes. If they don't tell you exactly how many they want, then it's your choice, and you can choose anywhere from 5 to 20, and you'll be in good shape. The downside is that if you choose 7 or 8, for example, and you finish up your frequency distribution and you take a look at it, maybe you say to yourself, this really doesn't tell the story. You might need to go back and change the number of classes to 13 and do it all over again. Last of all, the possible good news there is if you're doing it with some kind of technology, you might be able to just change that 7 to a 13, hit one key, and everything will change. Well, that's pie in the sky perhaps, but I think that's quite possible with some kind of software. Next, once you've got the number of classes, you have to figure out how wide the classes are. How far is it from one class starting to the next class starting? Sometimes there are natural divisions. In fact, a good example would be if you wanted to go by decades. 2001 to 2010, 2011 to 2050, and so on. Or there might be some numbers like maybe weights, where you go 0 to 10 pounds, 10 pounds to 20 pounds, and so on. It depends on the data set, what you're actually working with. To get that class width, what you're going to do is, first of all, you're going to calculate the range. And to get that range, you're going to look at your data and find the highest value, and you're going to subtract the lowest value. How far does it go from lowest to highest value? Subtract those, and what you have is the range. And you're ready to go. With the range, you're going to divide that by the number of classes, the one you just determined in the previous decision. Now, sometimes that might not come out to an even number. If it comes out to an even number, you've got what you need for the class width. If it comes out to a 2, for example, that's going to be your class width. If it comes out to be 3.7, for example, you're going to have to round that up. Remember, rounding up. You don't round it down. You need to round it up because you want to make sure that when you take an accounting of all those data items, every one of those falls into one of those classes. There are no gaps, and there's room for everyone. Third, once you've got the class width, and you start creating the class limits, the lower class limit, which we have mentioned up here, is where you're going to start. Now, for class number 1, or row number 1, it's going to go from one value up to another value, like this. One of the ways you can do that is you can take the data and take the lowest value and make that where your first class begins. What we'll see in one of our examples is maybe that doesn't look quite as nice. Maybe your smallest data item is 43, and you decide, this would look a lot better or work a lot better if I just made it start at 40. That way 43 would fit in, and maybe you take it up to 49, so 43's got a place, and maybe 45 is another data item, it's got a place, and so on. So the first class, 40 to 49. So maybe the second class starts with 50 and goes up to 59. And keep going like this. One way, once you get these numbers in the first class set up, 40 to 49, you're going to take your width and you're going to take 40, the one you're starting out with, add the width you just calculated and round it up. That should give you where the next one starts. In fact, what you should do is take this first column, class lower limits, take where you're starting, add the width, that's the beginning of the next one. Take the next low limit, add the width to it, and you get the beginning of the next one. If you take all this first row again until you've gone as far as you need to, then you can go up here and say to yourself, okay, if I start with 40, where should I stop? We'll just look down here to where this next one starts. Well, 50, okay, so the previous one will only go to 49. 50, where's that go to? Well, the next one starts at 60, so you want the previous one to end at 59. Do this once or twice and it'll make total sense if it didn't before. And make all of these classes, starting with the lower limits first, fill in the upper limits, and you're ready to go. Next, what's the frequency of each class? In other words, go back and look at all your data. Maybe you've got 60 pieces of data. And what you're going to do is you're going to look at each piece of data and see where it fits. So, for example, if the first column looks like this, these are the x's or the data values, and maybe the first class is 40 to 49, and that's your first row, and here's your data, and maybe the first data item is a 43, maybe the next one is a 52, all those data, maybe they're listed from lowest to highest, or maybe they aren't, maybe they're all mixed up. But this will work either way. So if your first data item is 43, you come over here, you got 1 in this class. Your next one is 52, okay, the second row or second class is 50 to 59, so you make a mark there. What you might also want to do as you're putting your data in the right classes, when you put 43 in, check it off. That way you don't have to look at it again. When you put 52 in, mark it off. That way you know which ones have been used and which ones have not been used, and you don't mark for the 52 value twice. You count it too many times. Next, you're counting those marks, and then you're going to make sure that your class limits, this is sort of not a trivial thing, it's important, but if you have whole numbers you won't have to worry about this. But if you do have decimal places, you want the same number of decimal places as the most decimal places you have in any one piece of your data. So if it goes to only down to tenths, then tenths is how your class limit should be set up. If they go down to hundredths, then you need your class limits to show the hundredths. Next, notice I mentioned this a little bit earlier. The class width is the difference between the lower limits or the upper limits. So if you've got a list of lower limits here, this one right here will have x plus w for the next class, x plus 2w for the next class, x plus 3w for the next class, until you've got the last class. And out here, you'll have this upper limit, and if this class goes from x to y, then the next class will end at y plus w. Y plus plus 2w, y plus 3w, and so on. If this doesn't make 100% sense, it will when you actually do this on just one frequency distribution. As you're putting the numbers in using the class width and the class lower limits, all of a sudden the light will go on or it'll click, whatever it is. You think, oh, well this is so logical, it makes total sense. Quite often, the first class limit will be the smallest number in your data. The lower class limit will not only be the smallest occasionally, but it will also mean it will be the smallest number that's in that can be in that class. And the upper class limit is the biggest one that can be in that class. It makes total sense once you see one, then you've got one coming up right here. So, first of all, this is our data. If you take a look at the numbers, you also notice that you've got a data angel working for you, because someone has taken all these items of data, pieces of data, and put them in order. The smallest one's here, and the largest one is here. Very nice. Next, we want to start constructing our frequency distribution. Here's the highest item, the lowest item. We're going to subtract them and divide by 7 classes that we're going to use. Remember, the classes can be usually between 5 and 20 if you were choosing. This would be the range here. This is the number of classes. Divide those, and here's the number you get. This would give you a class width, but you probably won't want to use 4571.43 as your class width. A little bit clunky as data goes. So you might want to just jump that up and make it something nice and even to make it easier to work with. Even better perhaps, since 4600 is close to 5000, you might actually want to make a class width 5000 instead. And that's a great one to work with. That's even more even, excuse the pun, more even than the 4600 is. So we might make the class width 5000. So in your table, your frequency table, each one of these will be jumping by 5000. And remember, the same thing happens with the upper limits. Each of these will be separated by 5000 or 4600 or whatever it is for your data. Next, we want a starting point for the classes. So instead of starting with the smallest number that we had, which was even, but it's not really even, what you might want to do is something like this. These are some nice looking classes. Start to 50,000, and when you're looking to see where a particular number fits in, it's easy to remember that they start at 50, 55, 60, 65, and so on, but even thousands. So if you see 57,382, bingo, belongs in here. It's over 55, less than 60, and you'll make a little mark here and say, I've got one in this class. Look at the next data item, maybe it fits in here. Keep doing that until you got all the data values accounted for, and then just add these up. How many do you have there? Maybe you end up with 3 there, maybe you end up with 2 there, and so on. those will be your frequencies. So we'll get the following frequency table. It'll look something like this with that data that we had a few slides ago. Take each of those data items and see which one of these classes it belongs in. Make a mark, and so on. And then check, okay, I've got 3 in this class, none showed up here, 6 here, 4 here, and so on. You'll notice something that you might think that this particular class is worthless, so leave it out. However, you would be incorrect temporarily, because having a 0 here in your table does relay some information. If we're talking about how much something costs, maybe it's, I don't know, make up something for yourself. There are no data items or values that are between 55 and 56,000. So none there. That's an important thing to see. You can see that here there are 3. There's a gap here for some reason. In fact, what this might do, as just a frequency distribution table, it might make you ask, as I'm looking at the frequency distribution, it says there's 0 in here. Is there a reason there's 0 of these things here? Maybe these are expensive cars, for example. Why are there no cars that cost between $59,000 and $59,999? Just something to think about. And statistics is all about thinking of what's going on. A big thing to notice here, the sums in the frequency column, add those up. It should be the same as how many data items you have to begin with. Class boundary. Now this is a little bit tricky, so be careful. Notice this was our frequency distribution back here without the marks. What you'll notice is there's a slight gap between each of those classes. Over here we've got 59,999, and here we've got 55,000. What if we had a data value that had 60 cents at the end? Where would that go? Well, it wouldn't fit in the class 1, it wouldn't fit in class 2. We've got a small problem on our hands, so we have to make sure we close up the gaps. That's what the boundaries are all about. So what we want to do is we want to change these class limits that we've got here to class boundaries, and what we'll do is we'll find the place halfway between the upper limit of one class and the lower limit of the next class. Okay, what am I talking about? Right here is the upper limit of one class and the lower limit of the next one. There's a tiny gap between those two, but one that might be significant when we're putting things into their proper classes. So, what we do is we find something that's halfway between. Well, not too bad, because if you need a boundary, you take the upper class limit and you add the next lower class limit, divide by 2, and that will take you halfway. Got it? Again, if it looks in the slightest as strange, once you do it one time, it'll be, oh, that is so easy. Because frequency distributions look complicated because there are a lot of steps, but every step is simple. You can do it even without a calculator, frankly. Next. So here are our class limits. We just saw that. So how do we close the gap? Well, we take these two numbers, add those two numbers, and then we'll divide that by 2. What do we get? Well, what we get is 54,999.5. And this one will be 59,999.5. Remember the class width was 5,000? Well, once you get this number right here, put the eyeball on that. Once you got this, the next one will be exactly 5,000 away. So all you have to do is find out what the top one is, and you're in business. Also, put your eyeballs on this compared with this. What's the difference between those two? Literally, what's the difference? Subtract them. The difference between this item and this value is 0.5. And what you're doing here is going from the class limit to the class boundary, you add 0.5. What you do on this side is take that 0.5 and subtract it on that side. So you add it on this side, subtract it on this side. So this class boundary would be 49,999.5, and you get your class boundaries. Once you got this class boundary, add an even 5,000, you got the next one. 54,999.5. Each one of these will be 5,000 more for your boundary. Lots of steps, but each step is simple. So this is how we calculate. Here's the upper class limit. Here's the next lower class limit. Add them, divide by 2, because you want something that's halfway between. There's your first upper boundary. Notice that the difference between this and this is a 0.5. Oops, not this one, sorry. There we go. And keep on going, adding 5,000. You can go the whole way through your table, frequency chart, just adding 5,000 once you got the first two figured out. So here you've got your frequency distribution with the class limits. Here you've got it with the class boundaries, and you're set. One extra thing, I mentioned this early, but you've probably forgotten that right now. Notice that this number and this number are the same. So if you had a data item that was 54,999.5, you wouldn't know which category to put them in which class to put them in. So remember, start with this in this class and go up 2, but not including this. If you remember your algebra, this would be what your class boundaries would give you for a class. It doesn't include the endpoints on the right hand side. You can actually include the first ones, although that will be pretty obvious. So you include the first one when you're looking at your data items to figure out where it fits in. On the second part, it does not include the upper class boundary. Include the lower, exclude the upper. Include lower, exclude the upper, all the way down. Next, now this is something that can prove handy, and this is the sort of scenario I'm going to give you for using class midpoints. Suppose someone hands you a frequency distribution. Alright, you've got the class boundaries over here, you've got how many are in each of these classes, and you've got various numbers we're going to talk about in a few minutes. But suppose you've got a boss. Your boss says, find the mean for all those data values over here. Let's suppose also that you don't have the original numbers. All you've been given is the frequency distribution. And the first thing you say is, well, where's the data? Where's the actual data? I need that to find the mean. And the boss says, somewhere in the process, it's been lost. The frequency distribution is all we have, but we do need to find the mean. So if you switch some of these to midpoints, and this is how you calculate a midpoint, just like we did for some of those boundaries, take the lower limit, add the upper limit, divide by 2. So the first one was 50,000 and 54,999. Remember that? These were the limits, and you can fill in here what the boundaries were. To get the midpoint, take the first number and the second number, add them together, divide by 2, and you get the midpoint. Now, how is that going to help? Well, if you don't have the original data, what you can do is sort of fudge it. So, you've got your classes with their boundaries. They're all in here. How about the data? You've got no data, but you've got the frequency for each class. So you don't know what these numbers are. All you know is maybe there are 3 items in here, and they're somewhere between this value and this value. If you don't know what they actually are, you could use the midpoint instead. So take this number, add this, divide by 2, and put the midpoint in here. And this midpoint is going to substitute for all those numbers that you don't have anymore. You can put those in your spreadsheet or whatever it is with the frequencies, and you can actually find out what the mean is and various other things. It won't be perfect, but it'll be close enough for you. So here's our midpoint calculation. Get the midpoint for each class in the frequency distribution. So there's our calculation. Add the beginning value for that class to the end value, divide the sum by 2, and you've got your midpoint. So this 54,999.5 is going to be your figurehead or your representative for all the numbers in that class, even though you don't know what they are. So this is what you're going to use. You don't have the data, which is over here, the original data. You don't know what you are. We know that we have 3 items somewhere in here. We have 0 items in here, and so on down the line. since we don't know what the data items are, this value is going to represent all three of these in that class. This number would represent that. If there weren't any there, this number will represent all 6 of those data values, even though we don't know what they are. That's our best guess. It's probably somewhere in the middle. It's your average piece of data for each class as your midpoint. Now, next one. We're moving on. We've got our frequency distribution begun. We've got a frequency column. Next, we're going to create a relative frequency column. Again, very easy. So for each class, you're going to take the frequency for that class and you'll divide it by how many values or how many data items you've got. So maybe you've got 3 items in that class. Maybe you've got 25 data items all told, 25 pieces of data. Your relative frequency will be 3 divided by 25. And 3 divided by 25 will give you 0.12. You might choose to write that as a percent instead. For another one, perhaps you've got 5 items in that class. You've got 25 items altogether in that data group. When you divide those out, you get 0.2. Now what I would suggest is you've got 2 decimal places here. If you just put your eyeballs on these 2, you see a 12 there, a 2 there, 2 looks smaller. But if you put a 0 there, keep the number of decimal places even, then you can go from here to here and you know this one has a greater relative frequency. And of course, if you do it by percents like this, it's easy to compare those 2 values. Next, occasionally when you're doing some statistics, you'll see this guy right here. It's a Greek letter sigma. If you've ever read about Greek fraternities or sororities, they usually are represented by Greek letters, typically capital Greek letters or uppercase. This particular one means you add things up. What's the total of all the whatever you're thinking about? In the case of frequencies, if you take all the frequencies and add them up, sigma will be the total of all those frequencies. Now, we can calculate the relative frequency for each class, like this. We get that number n, which is the grand total of how many items we've got. Just add up all the individual frequencies. We had 25 data items way back when we showed you those data items. So you're going to take each individual frequency. Frequency for class 1, frequency for class 2, frequency for class 3, and so on. Each one, say for the 3rd class, we'll take that frequency and divide it by the grand total. And that will give us our relative frequency. Maybe 0.13, for example, which if you like, you could replace that by using a percent instead. So here we've got the relative frequencies for this group of data. With 3 data items in this class, so we took the 3 divided by how many items we've got. That's our n. Whoever made these slides forgot to put the decimal point in here. You got on the rest, but not on this one. Notice also the second one has zeros. You might want to throw an extra 0 in there. That way you can line up the decimal points. It makes it easy to compare. And down here you got 0.4. Oops. We'll make that 0.40 to make it easier on our eyes. Next, if you want another double check, remember we had one check, add all the frequencies, and that should equal the number of data values you got in all of your data set. Another check is if you take these relative frequencies that you just calculated, add those all up, it should be about 1 if you take the decimal values, or if you have them in percents, they should be close to 100. However, if you had 7 classes, for example, some of those relative frequencies are not going to be even numbers, even percents. So when you add them up, there's going to be some rounding error. So instead of seeing 1, you might see 0.995, for example. Close, but not exact. Or you might see 1.01. The point is, it should be close to 1 if it isn't 1 exactly. If you're using percents, you might see a 99.5 for the total of the relative frequencies, or you might see something like this, 3%. It's close to 100%, and because the problem, you're likely to think, okay, I'm good. I did everything correctly. But if you get something like 78%, you probably made a mistake somewhere. You need to backtrack to find your mistake until it's close to the 100% or to the 1. The next item is cumulative frequency. So this is very closely related to the frequency. It's also, again, very simple, but you have to do it once or twice, and then all of a sudden it'll click and you get it all. So it represents how many frequencies you have from that class and all the previous classes. So for example, on this one, if you look at this class, its cumulative frequency, since this is the first class, there are no previous frequencies. So it's just 3. Easy. Next class, you've got none in here, so your cumulative frequency is 0 plus what your total was up to that point. If you want it for this one, you take this number, that's the frequency for that class, there's the 4, and all the previous classes. This 1, and there's the 1, and these are all the previous frequencies. Add those up. 3, this is the same because you only add in 0. You add in 6 because this is the next class. Add 6 to the 3. Add 4 to the 9. You get a 13, and so on. Another double check, just like with the relative frequency, is adding to 1. The last cumulative frequency should be equal to the grand total of how many data items you've got in your whole data set. So we've got an example here of the number of miles of professors in a certain department. And we're going to play with this a little bit so you can see how this works again. So here are the actual numbers, and I would suggest why don't you stop here, see if you can do all this yourself. Get the data items, get the class limits, the class boundaries, the frequencies, relative frequencies, cumulative frequencies. See if you can do that all yourself. Notice where you are in this video. Stop it there. Go back if you need to, pick up some extra things that you didn't quite understand on the way through. See if you can do all this yourself. It'll be a great feeling if you can. So pause it, come back later. I won't have to wait because I'm moving on. Okay, you've taken a pause, you worked it out. The example called for 6 classes, so you don't have a choice. It is between 5 and 20, so you don't doubt that this is probably a good number. Now, this was the largest number of miles the professor drove to school. This was the smallest. These two give you the range. You divide it by the number of classes, and there's your number. But you remember the class width has to always be rounded up. You've got the 1.8, so you're going to use 2 for your class width. Then you'll put in the class widths. What do we have? The smallest data item was this 1.0. The class width says, okay, 1.0, the next class is going to start at 1.0 plus 2, 3. The next class is going to start at 3.0 plus 2, 5. Add 2, get the 7, add 2, add 2. How do the other ones go? This goes up to 2.9. We don't have to figure all that out again. All these are separated by 2, so add 2 to the 2.9. Here's the next one, 2 to the 4.9. Got it? Add 2 again, add 2 again, and you've got all the class limits. You want the boundaries? Take the upper class limit for the first class, the lower class limit for the next class, add those, divide by 2, and there is your first class upper boundary. And notice in going from here to here, there's a difference of 0.05. So then you're going to take that 1.0 to get the lower class boundary. You'll subtract that 0.05. So your first class will start at 0.95 because you subtracted them. So this is what you'll have. See, here are the classes you had just a few minutes ago. There's a gap between those two. Just in case, for example, all of a sudden we've got a professor we forgot. Well, we can find exactly where he belongs. There will be no gaps between here and here. And remember, in the class boundaries, this class boundary goes from here up to, but not including the 2.95. Starts at 0.95, does not get the whole way to 2.95. So if we have the new professor drives 2.9, 2.92, and he will belong here. If he drove 2.97, then he would belong in the next one, because that will fall inside this, but not to 4.95. Take a good look at this. Just for fun, see if you can go through here and try to find any mistakes. I am pretty sure there are no mistakes, but check to see how they calculated these boundaries, for example. and see if they're correct. The only mistake that I see here is that this looks as though you're taking everything from 4.95 to 6.95, and you're not. You're taking everything from 4.95 up to, but not including the upper class boundary. That way, everything has a place, and you can find the proper frequencies for each class. The relative frequencies, here's how many professors are in this group, the 3 classes. This is how many professors we had total, so we can get some meaningful information from our frequency distribution chart. So, just a final reminder, the relative frequency is the ratio, so you get a decimal point or a percentage, represents how that class compares to the whole group. Cumulative frequency is a running total of how many data values you've got, or how many frequencies you've got to a certain class. Well, with any luck, that's about it, folks. If you have any questions, contact me. If you don't, I'll see you again in section 2.2. Maybe that'll be tomorrow when I can record that. Until then, keep smiling and I'll see you.